So what we're going to do is, again, we're going to be creating a blank dictionary and a simple for loop. The for loop basically works like this. If you have your Ingram in your Ingram list, so going through every single one of these, and then for the actual Ingram, the thing that for the count for that dictionary entry, you want to use this little bit of code. And what it says basically is use this function to get this Ingram entry. So it's basically looking for the entry and to see if it already exists. If it already exists, add 1 to it. If it doesn't already exist, make it a 0 and then add 1 to it. It's basically just going through it and checking what it is. This, under normal circumstances, would probably be in something like, if it had been rather variable equals variable plus 1. This variable here, this variable, you have to do this in order to get it, just in case it's blank, so that it knows what to use if it's blank. It uses this 0 instead of throwing an error. So if I use this little bit of programming code now, and I run it, it will take a minute to run, I'm afraid. Should have just left it up. So I'm going to restart just so that I can see what it's doing. Okay, so again, if I open up my data file, make sure it's in there, lowercase, regex, split the data, create the Ingram list. There we go. And now we have our dictionary appearing. And every dictionary entry will be one of those 3-word phrases with the number of times it appears. Now, while it's doing that, we'll move on to the next little bit of it because it is taking a long time to kind of process it. Once we have this dictionary entry, it's going to have those 2 bits of information, the string and the number of times it appears. So is there something interesting we can do with that information? Well, yes, we can try to figure out what is the sub list of those things that meet certain parameters. So for example, for Ingram, tally in count.items. And what this is basically saying is that this output, which is going to be every Ingram, comma, every amount that it appears in this dictionary. So within the items of this dictionary, look for this combination of words and tally. Then if the word black, for example, appears in the Ingram, print the Ingram plus that little bit of helper text plus the tally. And remember, tally is going to be an integer, so you do want to turn that into a string. And if I run that little bit of programming, this is a much shorter list, so it can actually handle that on my computer right now. You can see that back to the black heath appears once. To the Blackheath Rains appears once, stiff black hair appears once, and so on. Through the black, for example, actually appears twice. In the black appears twice, and so on throughout here. So for example, if you wanted to see the context in which the word Maria appears, I don't believe it does actually appear, or the context he appears, that's probably too much, but we'll try it anyways. You can see it appearing over and over again throughout this system. Yes, we can order the list by frequency. So if we go through here, just so that I can see what I'm doing. The next thing we really do want to do is we just want to see the order that it's going down. So we did this before with a while loop. So the largest number, we want to find out which tally has the largest number in the entire set. So for the Ingram tally in count items, let's see here, value equals 0. If tally is greater than the value, value should take on what tally is. And what this will do is we'll go through every single tally we have and figure out which one is used the most. And if we go through that, we'll see that the phrase that comes up most comes up 71 times. Okay, so what do we do with that? Well, let's change it around. So for every Ingram tally in count items, if the tally is equal to the value, print Ingram plus that little bit of helper text plus the tally. And then what we want to do is we want to go through and lower the value. So for Ingram and tally, in count items, while I is greater than 0, after it goes through all the Ingrams and looks for all the 71s, what we want it to do is to make I equal I minus 1. And then go back through the list again. While I is greater than 0. You do get all these little typos. There we go. So as you can see, it's doing this over and over and over again. Because said Mr. Graham, why is it doing that one over and over again? Does it do this for all time? No. While I is less than 0. Oh, we forgot to make value. There we go. So here we go. And now it is in order. So I think we didn't actually need any of that. Let's just double check. Yeah, that's working fine as is. I overcomplicated it. So what it does now is it goes through every list and it does reduce the value. So said Mr. Laurie appears 71 times for some reason. Out of the appears 51 times. There was a 46 and so on and so on. So you do have to sometimes think about how you want to organize it in order to create those loops to go over and over again, but there is a very easy way to do it in most cases. Okay, so the next thing that we're going to do is we are going to try and figure out a way to present this information in a more digestible format. A lot of times when you work with data, what you're really trying to do is to create a visualization that you can use in an article or a presentation, or really just in your own research in order to demonstrate how that is useful. So what we're going to be looking at here is something that is called a heat map. Now, a heat map is, generally speaking, a visualization of when and how often something appears in a given space, in this case, in a given text. So what we're going to do is we need to create, first and foremost, a dictionary that has the information that we need it to have. And by that, I mean the location data for each individual instance of each individual word. So for example, if we go back up here and instead of turning our Ingrams into these little 3-word Ingrams, we just want to use the data, the original text words, just the words as they appear individually. And for each of those text words, we want the following thing. We want the word in our dictionary, and we want a list of where that word appears in our text. So maybe the word appears as word number 1, word number 258, word 35,468. And then we can visualize that essentially as a heat map or a barcode of where all of those different instances of that word are. And this can be really useful when you're trying to figure out how often a character appears in a book, if they appear mostly at the beginning or the end. If you're doing a document and you're trying to figure out where they're foregrounding certain arguments, you can look for that argument. It's the beginning, the middle, or the end, things like that to sort of figure out what you want to express. And it's also really useful for comparing and contrasting different characters or different ideas in the same text. So we did create a very simple dictionary, which had our count or how often a certain Ingram appeared in the book. But now we want to know what words it actually is appearing at. So there's a pretty good, pretty simple way of doing this. So we want to create a new dictionary, and we want to call this location dictionary because this is where each word is located in our text. And we're just going to save that so it's empty and nice and not going to get hurt. And we also want to create an iterator. So I or counter, if that helps you understand what it is better. And we want to start at 1. And why we want to start at 1 will become clear in just a moment. The next thing we want to do is we want to create our for loop. Now, this for loop is going to be a for loop with an if conditional inside of it. So what we want to do is we want to say for word in text words. So every word that is in our text words split folder file, we want to get what that particular word is. So first we want to see if that word is already in our dictionary. So location dictionary.get/word. Now, in this case, we don't want to put anything there if it's not in our dictionary. We just want to find out if it is already in our dictionary. We've already seen that word once before. So this will either become a list of everywhere else we've seen the word, or it will come up with something called none. If entry is equal to none, if nothing's been put into our dictionary so far, and remember to use double equal signs there, then we want to start it with our first entry. So location dictionary for that word is going to be equal to our counter, which in this case is just 1. If the entry is not none, that means it is a list. It's already a list of different values of where that word has begun. So if we want to add a value to our entry, we just use append. So entry, append, counter, which in this case, again, the first time through is going to be 1 again. And then our location dictionary for that word, we're going to replace it with the new version of our entry. So I'm going to just write sort of an example of that before. So if our dictionary does not have the word the, it looks up the and it gets none. So it takes entry and it replaces it with what word we're on. We're on the first word. And so the entry for the becomes 1. Which is another important. So you don't want to have just the counter. You want to have the counter as a list. It's a list with just that 1 number in it. If the counter, if the already had a list in it, entry would be adding that new number onto it. So it would become that. I hope that makes sense. You're basically just asking it, does it have a list already attached to it? If not, make a brand new list that only has what number we're currently on. If it does have a list, add our number to it and replace that entry. At the end of all of this, we do want to add and assign 1 to our counter. Because when we move on to the next word in text words, we're now moving on to the second word or the third word or the fourth word. Now, if you've missed any of that, it is all available in that gist for you in slightly more detail. But if we run this now, it has now gone through our entire dictionary and is providing that information for each of it. So now if, for example, I do location dictionary for the, it does not find it. So let's just have a quick look. So for some reason, my count dictionary is not being created. Okay. I just realized the typo that I made previously. Yes, okay. So hopefully this should work now. Yes, okay. Okay, so now when I print the location dictionary for the word the, I end up this huge, gigantic list of numbers of every time the word the appears in my entire dictionary. Well, that's why you don't want to print your entire dictionary, because that will be a gigantic file. And it's not really useful if you're trying to do any kind of analysis on it. So we want to have some kind of visualization. So the next thing we want to do is we want to get rid of all the words that are, shall we say, stop words, words that are not going to be very useful for us going forward. So you can get stop word lists all over the internet. For me, I'm going to use a stop word list that I found on GitHub. You'll be able to find it inside that folder. And what this stop list word does is it's basically the most common words in the English language with the punctuation taken out. So like there, they've, they'll. And these are words that we're not going to be interested in. They're words that we're not going to want to use in our visualization. So the next thing we want to do is we want to create our actual diagram. And the way we do that is we're going to use a really powerful library called matplot library. And you have to import that by going from matplotlib import pyplot as plt. Now, that looks very different to maybe the way that we've imported things before. And that's because rather than importing the entire library of matplotlib, which is very large, we're only importing the sub-library called pyplot. And pyplot is normally abbreviated to PLT, just so that if you're looking at other people's programming code, that's how they normally do it. So we're going to abbreviate it here as well. So once we've imported that, then we want to create a diagram. And the way we create that diagram is pretty simple. We want to put what that diagram's size is going to be. So how big we want that diagram to be. So PLT figure, fig size equals, and the two numbers that you put in here are length followed by height. And for the purposes of this particular program, what we're going to want to do is to do a 10 by 5. And that will pretty much take up the same space as one of these little bars. So it'll fit nicely on your screen. The next thing that we want to do, and I think the best way of doing this, considering we're a little bit short on time, is if you go to that file I sent you, that GistHub, there is a set of instructions that you can put in there that look like this. I'll just put it in here like that. From instantiate the figure down to show and close. And if I run that little bit of software, you can see it creates this graph. Now, this has a lot of functionality, and unfortunately, we just do not have time to go through all of it today. But you can kind of see that this is the size of the figure. So that's how big it is. You can see that each of these bars that appear, black, blue, and red, have numbers. So at X1 and Y2, it is red. So it's underneath that black one, so you can't see it. So black. So at 1, it goes up to 4, and at 3, it goes up to 1. So at 1, it goes up to 4, and at 3, it goes up to 1. And you can kind of see how you can kind of create a chart doing this way. You can have a legend where it has my title. You can have tick marks where you say what numbers appear on the sides or on the bottom. All of this functionality is available in Matplotlib, and it's really, really good for creating mathematical visualizations as you go along. For ours, however, we're going to want to just figure out what is the top 5 or 6 words that exist in our collection. So as I said before, when we went through our 4 Ingram tally in count.items, there it goes. Okay, so this little bit of programming is just what we did a moment ago to figure out which one had the highest value. And the highest value word in all of our instances in our dictionary is 8,203. So 8,203 is the dictionary entry that has the most entries. And if you kind of want to see what I did, I basically just went through every single word in our dictionary, counted the length of its instances list, and then kept replacing it every time I found a bigger number. And that's how I ended up with that 8,203. So once we have that big number, we want to find out what the top 5 numbers are. We don't need to have a running list of every single one, just the top 5. So we create our new list of top 5 words that exist. We have our starting value of 8,203. And now we create our while loop. So while value is greater than 0. So as we're counting down from 8,203, for every word and list of instances that is in our location dictionary, we want to see if the word in that particular entry has a list of instances that's as long as that value. So if the length of instances is the same as value, and if our top 5 list is not already full, and if the word that we're looking at is not in our list of stop words. So that's quite a lot of conditions. It has to be the biggest number we've come across so far. It has to be that our top 5 is not already full, and it has to not be one of those little short words that nobody wants in their top 5. And if all those conditions are met, then we go ahead and append our current word to our top 5 list. After we're done with that, we want to do value minus equals 1. And make sure that that value is kind of in line with the beginning of your for loop. So after it goes through every single word in your dictionary, lower the number it's looking for. So next time, is it the 8,202 instances? Then the next time, is it 8,201 instances? So just to give you an idea of how long this is going to take, it is going through every single word in that book 8,203 times. So it is a very large number. Once we're done with this and we run it, it will think for a moment. And when it's done, we can go ahead and print our top 5 values. Project Gutenberg ebook Tale and 2. Of course, those are going to be the most common words. Okay, so what this basically would mean is that you need to go back into the Tale of Two Cities document, and you would want to remove all of this information that is about Project Gutenberg, which is the very beginning and the very end of the file. Now, I'm not going to go back and rerun all those processes again. Well, actually, I am, just because it'll make it more sense later. So if I go back and re-import my data file, make it lowercase. This is just a nice recap for us. Get rid of all of the punctuation. Split it into individual words. Create a list, a dictionary of all of those words. Create a location dictionary of all of those words and their values. My stop list is fine. And now if I go through and look for my top 5 again, and then reprint that top 5 list. Chapter, period, best, times, and worst. And that makes a lot more sense in terms of the top 5 words that are appearing that are not stock words. So what do I want to do here? Well, I want to create a new diagram that's going to show all of those different parts. Now I'm going to just paste this in here and then talk about it piece by piece, and you can go ahead and type it in as you go. So for each of these words, for top word in top 5, chapter, period, best, times, and worst, I want to make a new diagram. So I tell matplotlib to create a diagram that's 50 across and 10 high. So that's a pretty nice size image. After it's created that individual graph for each of these words, for every word and instance pair in my dictionary, if the top word is equal to the word. So remember, our top 5 words list only has the words. It doesn't have any of the instances in it. So we have to basically look up what those word instances are. So if it goes through the location dictionary and finds that word, it creates a bar, a single bar in this bar chart. And that bar uses the instances data, all of those numbers, to be all of the X coordinates. So if it was at word 1, word 2, word 7, word 14, those are all the X coordinates across the bar. The Y coordinates, how tall the line is, I just made 1. So they're all going to be the same height. I've labeled that particular bar by the word, so whatever word it's doing. And just because we're going to be doing so many bars and they're going to be so tiny, I've made the width 10 to make them quite chunky. And then I've added a title which makes the skin, it's just the word, but I've made it pretty big at size 30. And then I tell it to show the chart. So if I run this information here, you'll be able to see that here we go. Here are the instances of the word chapter, and these are exactly where it appears in the text. If we look at the word best, here is where the word is appearing throughout this entire times as it's appearing. So times gets talked about quite a bit at the beginning of the book and at the end, but not the middle. And if you compare worst, worst is done pretty much throughout it. And best is done only in this section and the last section. So worst is pretty evenly divided, whereas best comes in sections within the book. So what this hopefully gives you an idea of is how best to create these sort of visualizations or these diagrams from your data. So the best way to sort of bring that up. Okay, so when we're talking about strings and how we can run information on them, what we're talking about in what you would search for is something called methods. That's what all of these things are. So for example, we had the string. This is a string with, okay, with text in it. Some of the most useful ones I can think of is first, we have lower, which we've already used, which will make everything in that string lowercase. Another good one is capitalize. And when you're doing things in Python, you always have to use the American English, I'm afraid. It's just one of those things. If you capitalize the string, what it will do is it will capitalize the first character to, so if this were lowercase, and then we do this, that would capitalize the text back up again. If you do something like count S, it tells you how many times S appears within that string. And you can actually do it with a quite lengthy amount. So is appears twice because of this, as well as is. What are some other good ones that I'm used to using? You can also ask questions of the text. So if you ask it, if you have a list of text and you ask is lower, that's basically just asking a question, which is all the text in that string lowercase? And in this case, it's not. If you do, this is my personal favorite, is title, it says false. And that's because a title or headline text should be like this, where you have capitalized letters except for the small stop words. So this should come back true, I think, if I do this. Yes. So if every letter of every word is capital, if every first word is capitalized, first letter of word, then is title will come up. If, for example, you have a string that has lots of extra spaces on it, you can also strip the remaining spaces and it will just cut it down to the end of your string. So you don't end up with lots of extra spaces that you don't need. Like to to sort of know. Is title, by the way, if you're doing something for a bibliography, for example, so you have a title like, this is the title of my article, and you want to turn it into proper titled text for your bibliography, you can also do this, and it will capitalize every letter for you. As I said before, there's lots of different strings methods that you can use to basically format the string in the way that you want it. I think what I just want to close today with is the idea of Matplotlib and kind of its value to you as academics and as researchers. When I began doing my research into newspapers, what I wanted to be able to do was to say that here's all this data I downloaded from newspapers. And I had basically this article appeared on this page, you know, and it was the first article on the page, or the second article on the page, or the third article on the page. And because I had all that OCR data, all that text data, I was able to create a program in Python that went through every one of those articles as though they were different strings, converted them into a number, so how long they were, using the length function. And then I was able to use Matplotlib to create a bar graph that basically replicated the visual version of the page. And by doing that, I was able to process dozens and dozens of pages of newspapers and have it color code different newspaper pages for me, that these were the news articles, these were the opinion pieces, things like that, using the data that I had to do it all programmatically. Previously, I was basically getting a piece of paper and drawing each newspaper and trying to figure out where these things were positioned on the screen. And because of simple for loops and simple functions like len and simple things like matplotlib, I was able to create these visualizations for lots and lots of data very quickly, and it really helped my research. So if there's anything that I would like you to do going forward, it's to have a look at the example the example plots that I have here, and to play around with some of the variables. So for example, if I turn upper center to upper right, the chart moves over to this side. If I change the Y ticks to 1, 2, 3, 4, 5, instead of 2, 4, 6, 8, 10, you can see that now this side only does these numbers over here. And so it just provides the ultimate in customization, something that you really can't do in Excel in the same way. I hope this has been useful to you. The other thing I would say is that the best way to get better at programming in Python is just to give yourself a project. What is something simple or mediumly complex that I would like to do, and figure out all the little steps that you need in order to achieve that. Most of the Python I learned for the first 2 or 3 years was completely non-systematic. It was just, how do I do this? How do I do this? How do I do this? And eventually you build up a library of how the programming language works and how you can get it to do what you want it to do. And hopefully these 2 sessions have given you the basic ideas about how you can use sort of your own thought processes to make the program at least automate some of the things that you do already. So I will leave it there, but thank you all for coming, and I hope this has been useful to you.